Hello, my name is Carlos Hernandez, and today I want to talk about DHCP starvation, which is a type of network attack. In this presentation, I'm going to talk about, first of all, how the DHCP protocol works in a network. Uh, After that, I try to define what is DHCP starvation attack. We are review some of the consequences of this attack, and the end I'm talking about how we can mitigate or prevent this kind of attack in our network. First, just like a summary of how the DHCP protocol works. Basically, it's used to the main feature is that we can assign IP addresses between a network for, and we don't need to assign all the IPs manually. Also, we can define a subnet mask. We can set the default gateway for all the network and the DNS server. Finally, we can set some parameters like the lease time. This is the time that the DHCP server assign a specific IP to a client. That a client this for this topic is any device that is connected to the network. And in the left side, we can see that how the DHCP works. We have a communication of 4 steps: the discover, offer, request, and acknowledge, or DORA. Discover, always the client start the request or the conversation. Discover, send package to discover the DHCP server. The DHCP server responds with an offer. It means the server say, hey, I can give you an IP address. The client, after that, send a request for a specific IP address. And finally, the request turn back the acknowledge that finished the communication, and the client gets the IP. Okay, after that, in a normal workflow in a network, all the users access through a switch or access point in Wi-Fi, for example, and connect to the DHCP server. I mean, all the users that don't have a static IP address connect to the DHCP server and ask for an IP, because obviously we need an IP in order to get internet or access all the network services. So every user that is connect to the DHCP server. This DHCP server assign a IP address, reserve that IP address, because two different devices cannot have the same IP. And after that, probably the users disconnect from the network or turn off the computer, and the DHCP server release that IP address and is available again. Now let's review what happened when the network is under attack with a DHCP starvation attack. In this scenario, a person, the attacker, connects to the network through a switch. We can connect physically to a port or through the Wi-Fi access point, and start sending hundred or even thousand of discover package to the network. Obviously, all these packets are sent and to the DHCP server, and the DHCP server start responding with offering IP. Let's say that we have this range of network from 192.168.10.1 to to 10.255 to the network. In this case, we have 255 IP available. In this scenario, when all these IP are reserved for the discoveries sent by the attacker, at this point, the DHCP server doesn't have more IP for other clients. In this case, if a network user tries to connect to the network, for example, somebody else turn on his computer or try to connect through Wi-Fi, he won't be able to connect, because when we try to get an IP, try to connect to the DHCP server, but this cannot respond because all the IPs are reserved. By the way, the attacker doesn't stay in the second step. The attacker gets the offer, but he doesn't respond. He stopped the communication, so the DHCP server keep reserved the IPs. Basically, this is how a DHCP starvation attack. Now let's look at some consequences. The first consequence, the obvious one, is that the users can get an IP address, and this means that the user cannot connect to the network services. Internet, of course, but also they won't be able to connect to other servers like database, web servers, and so on. Also, this can mean that the network can have a denial of services. The services can be interrupted. So in this case, without enough security, all the network can be interrupted, and this can mean some services, important services to the final users, like web page or transaction, I don't know. But also, and more important for me, is that this kind of attack can compromise the network for future attacks or other kind of attacks. For example, we have DHCP spoofing. This means that what happens if the DHCP server cannot respond to new IP requests? Well, in this case, if the attacker, as we can see in the diagram, like a laptop in orange color, if the attacker implement a rogue DHCP server, this is a fake DHCP server, all the users that try to get an IP, probably if the original DHCP server doesn't respond, are going to try to find another DHCP, and the attacker can get all that information. In this scenario, the attacker can get MAC address and probably discover all the or part of the network structure, and this information can be used to attack another server, so try to get some secure information. Okay, now let's review some of the things that we can do to mitigate or prevent this attack. In Windows Server, we have two configurations that we can use to try to mitigate this attack. Authorize the domain services. This means that in the network, only this server can assign IP to the clients. This is important so we can prevent some attacks or rogue DHCP server. And the failover, in this case, we configure that what happens if the actual DHCP server fails, or not only for attack, probably even physical damage or something happened to the DHCP server, we have a second DHCP server that can respond for new IP requests for the clients in case that the main DHCP server fails. Also, there is a good practice that is network segmentation. Probably we can segment the network in small groups or departments, for example, that in case that an attack, the DHCP server only affect or fail in this department, so all the rest of the network is continuous working. How we can do for prevent this attack? Well, in the latest years, some of the network devices allow us to implement some security features, like port security. This is that we set some feature in each port of the network, and for example, we can limit the number of IP that clients can get in each port. For example, in this diagram, we can see that the DHCP client is connected to untrusted port. This means that this client cannot assign IP. For example, if attacker in the right side connect a computer and try to implement rogue DHCP server, if the port is untrusted, so this server cannot be able to assign IP. All this traffic to assign IP, it will be blocked. So this kind of features prevent. Also, we can prevent the number that IP that can be assigned for each port. For example, if we configure a Wi-Fi access point to only assign 20 IP, even if attacker try to request 100 IP, he only be able to get 20. So we can prevent the starvation of the IPs. I think that this is only for some Cisco devices, but but it's only not all of the devices allow us to configure this kind of thing. But this is a good point to try to prevent this attack. Finally, we have some software to monitor the network, like IDS or IPS, intrusion detection system and prevention system. This software allows to monitor and respond to some strange behavior in the network. They are very useful, and for some networks are a must because they can help us to improve the security. My conclusion about this topic is that sometimes I think it's easier to attack that defend a network. The DHCP server is very common nowadays because it's insane try to set manually an IP address for each computer or for each device. For example, Wi-Fi access point is the only way to offer IP address to the clients. But network manager is probably one of the most important thing. We need to learn how to try to prevent this kind of attack and other attacks, but also we need to follow the best practices and try to monitor the network and have a risk plan and try to respond as soon as possible for all these kind of attacks. Thank you. This is my references, and thank you so much.